Hello, welcome to Basics of Sets, Set Notation, and Venn Diagrams. Before we begin very quickly, once we finish the basics, here are, very briefly, the examples that I plan to cover so that you know where it's coming from. So looking at this, the key word, now before we begin, let's talk about a set. And the key word here is a collection. It can be a collection of letters, numbers, fruit, insects, whatever it is we're discussing. And an element is a keyword member. It is a member of a given set. And a real quick example. This is set A and this is set B. And that we'll kind of use that as we're talking about the basics. The key word here is or. And the symbol we use to notate that it is a union is a handy dandy U. And basically a union would be members that are in set A or B. So in our simple example here, you can see that the members of this would be D, E, K, Y, and Z. Keyword with intersection would be or, and the symbol for an intersection is A. It looks like an A. The keyword is, oops, error, and. So looking at this, this means members that are in set A and B. So in this case, our little handy dandy example, you can see the only element that is a member of both sets, A and B, would be E. So let's go to a slightly more complicated example. So looking here, we can see we are looking for the intersection, and. So looking here, let's see which members we have in common. We have a 3, and it looks like that is it. Oh, I missed it, and a 9. So that would be a 3 and a 9. Looking at the next one, it is a union. So these are members that are in both, basically. So in this case, it would be a 2, 3, 4, 5, 6, and 7, 8. Wow. And that would be the union. Now we're looking for the intersection. So we are looking for members. Oh, one mistake I made. Example 2 has two different sets. So let's go ahead and erase this. So example 2, let's give you these numbers here. Example 2 has set A is 6, 7, 9, 11, and 12. And set B is 10, 13, and 9. And I'm asking you to find so looking here, we are looking for members that are in A and B. And if we look here, we can see the only place that that is true is for the number 9. Now we're going to look at or. So members that are in A or B. In this case, that would be 6, 7, 9, 11, 12, 13, and I almost forgot number 10. And that would be the members that are in both. For example 3, we have two different sets. And so for example 3, we have 1, 2, 3, and 4. And for set B, we have 5, 6, 7, and 8. And I am asking you to find the intersection and the union. So looking at this here, we look at the intersection, and looking at this, you can see they don't have anything in common. And so this means empty set or null, meaning they have nothing in common. So here, we're looking for the union, and hopefully you remember that union means or. So that would be on either set. So that would give us 1, 2, 3, 4, 5, 6, 7, and 8. And that's not a 5 that we can read. And so there we go for example 3. Okay, so moving on now to the Venn diagram. So for a Venn diagram, it consists of a universal set, the notation is U for universal set, and it is represented by a rectangle, which is the universal set, and subsets, which are represented by circles. So, looking at this for example, the only thing that I needed to cover was, hopefully you can see here, that would be what are in both sets. So if this were set X and this were set Y, that would be in set X and Y. So going here to, now we're going to use for these examples, U is the numbers 1 through 8. So for A, what example are we on? It's probably nice to know that. Okay, so we are in example 4. So we are looking for, first, before we start example 4, sorry about that, we are given that A is 1, 3, 6, and 8, and B is 2, 3, 4, 5. So what this means here is that the universal set is the collection of everything we're discussing in this problem. And then we are given sets, A and B, and notice they have different elements and some elements in common. So we're going to start by making our Venn diagram. And noticing before we even start that the number 3 and the number 8 are in common. So we're going to put them in this center overlapping region, meaning it's in both. And then in A we have a 1 and a 6, and in B we have a 2 and a 4. Now the only thing not to forget is this is the universal set, or the collection of everything we're talking about. And as you can see, we do not have the number 1, 2, 3, 4, 5, or 7. So we have to show that 5 and 7 aren't in either set. And that is a Venn diagram. Moving on to, this was example 4. Moving on to example 5. A is 1, 3, 6, 7, and 8. And B is 3, 6, and 8. So we're going to build a Venn diagram here. Be sure to label which is A and which is B. And looking at this, we can see 3, 6, and 8 are in both. And then if you look, we can see in set A, there is also a 1 and a 7. Now notice there are no members of set B alone. So what you need to do is redraw this, because you can see B is a subset of A, but there are no collections in B, so that would be A and B. And so this would be a 3, a 6, and an 8. And this would be a 1 and a 7. And then the only thing we want to make sure we do is account for all other members that are in our universal set. And if you remember at the beginning of the problem, we talked about the universal set was 1 to all the way through until 8. So now we have to account for there's a 1, we have no 2, a 3, no 4, or a 5, 6, 7, 8. So now all numbers in the universal set are accounted for, and we can see B is a subset of A, and which elements are in both, or simply A or neither. So now we are going to, I'll step aside so you can see that for a moment. And now we are going to move on to our next example. And looking at our next example, it would be the End of Crating Pigs Club. So we have total 27 members. Black hair, we have 19. Brown eyes, we have 14. And having both is 11. So in these types of problems, it's easiest to start with a Venn diagram. And one of the common questions I get from students are, how do you know when to draw a Venn diagram? And notice we have a collection. We have shared characteristics and then ones that aren't. So this is a very good visual representation of what's happening in the problem. So in this case here, let me make sure I didn't forget anything, and I did not. So here, 11 is the overlap. Now to find, we're going to do black hair and brown eyes here. To find the number that only have black hair, we're going to take 19 and we're going to subtract the overlap, which gives us 8. And then to find the ones have only brown eyes, you're going to do the exact same thing. And you're going to do 14 minus 11, and hopefully you get 3. Now we're ready to answer the questions. So we are asking first, how many, I don't know what we're asking, how many have black hair or brown eyes? So how many have black hair or brown eyes? And I hope you are okay with. That is an intersection, the number that have black or brown eyes. And that's going to be, notice there's no overlap, we subtracted. So it's going to be 8 plus 11 plus 3. And I'm hoping you get, when you do your math, 22. So it means 5 have none, neither characteristic. Then the second part of the problem asks, what does it ask? How many have black hair but not brown eyes? And you look at your Venn diagram and you can see that would be 8 for our second answer. And now we're going to go to our final example. Okay, our final example is a diving team. We have 25 total. 18 have dogs. 17 have cats. And our job is to find how many have both. And hopefully you're okay with, if it's both, it's going to be dogs who have dog and a cat. And that's the correct notation that we're finding for the intersection. We're going to start by making our diagram. And looking at this, we're going to see that, so we don't know what this is, so we're going to call it X. Because we know where the overlap is, that's going to be X. And looking here, if you subtract the number of dogs from the overlap and the number of cats from the overlap, I forgot to label, be sure to label which set is which. And so now we have a little equation. And we know there are 25 total. So that's going to tell us you're going to take 18 minus x plus 17 minus x, and that's going to give us 25. And so then you're going to clean it up a little. And then I'm hoping we're okay with this math, and we're going to get, because 18 plus 17 is 35, and negative x plus x is 0, minus x is negative x. So we're going to subtract 35 from both sides. You can't have an answer negative x, so you have to divide by negative 1, and 10 of them have for both. And then if you were requested, if you know this is 10, then you do 18 minus 10, so 8 have only dogs. And then you would do 17 minus 10, 7 have only cats. So it depends what the problem's asking you to do, where you go from there. And that is our basics on Venn diagrams and set notation.